Hello everybody. Today we are going to start tutorial for chapter 3, okay, which is about particle equilibrium. Just a quick overview. So here if we have, let's say, a particle, okay, and we have different or a multiple of forces. So what we are going to do is that we are going to apply our equilibrium equations for this particle, okay? So we have in 2D summation the forces, the x-axis equals to 0, and summation of the forces of the y-axis is equals to 0 also, okay? In 3D, we will add also the summation of the forces in the z direction equals to 0, okay? Also, we should know that if we have like a spring, okay? Let's say here's our spring, and we have a force F. So the force in the spring is equal to Fs K spring constant multiplied by S. That's stretch, okay, in the spring. It can be either contraction or elongation, or in some books it's like called delta X. Okay. So here let's say here is our original length and knot, and here is our stretch S or delta X. So here is the total length for the cable after the stretch or after applying the load. So here is like the final length of the spring. And also if we have like a pulley, okay, let's say here we have a pulley. So the force in the cable is always, as you know, a tension force. So here's T1, and here let's say it's T2. But in the cable we will have always the same force, the tension force. So T1 is equal to T2. So we can say here like T and T. Okay. It's an easy chapter, so let's begin with our first problem. If cable CB is subjected to a tension that's twice that of CA, so TCB is equal to 2 TCA. Determine the angle theta. Determine the angle theta for equilibrium of the 10 kilogram cylinder. Also, what are the tensions in wires CA and CB? Okay, so what's required is that we should find out theta and TCA and TCB. Okay, in 2D, it's a 2D problem, so the maximum number of unknowns should be 2 unknowns. Why? Because we have 2 equations, summation of forces. The x direction equals to 0, and summation of forces in the y direction equals to 0. Okay, so here I put the coordinate system. So x-axis is the horizontal axis and y-axis is the vertical axis. Okay. Here, the weight of the cylinder is equal to mg. So m, the mass is given to be 10 kilogram. Okay, multiplied by the g9.81, and we will get the weight to be 98.1 in newtons. Here, the theta is required, is unknown, and here the angle is given to be 30 degrees. Okay, so we can note here we have how many unknowns, like the theta and TCB and TCA. But here you can say we have 3 unknowns, but actually we have 2 unknowns. Why? Because here it's given the hint that TCB is equals to 2 TCA. Or you can say, okay, 3 equations, sorry, 3 unknowns. Here we have 2 equations, and here is the third equations. Okay. Now you can see here I took the summation of forces the x direction. Okay. So TCB cosine say theta, okay, it's positive because it's directed in the positive x-axis, minus TCA cosine 30. okay, equals to 0, because here we are in statics course. So from equation 1, we can use this hint TCB equals to 2 TCA, okay? So here we can replace TCB by 2 TCA, okay? So we can use here 2 TCA cosine theta minus TCA cosine theta equals to 0. Here we can cancel TCA out, and we are left with cosine theta equals to cosine 30 over 2. And when we take cosine inverse, we will get theta to be 64.3 degrees. Now, taking the summation force in the y direction, we will get what? TCB sine theta, it's acting upwards in the positive y direction, plus TCA sine 30, also positive because it's acting upwards, okay? So here TCB sine 64.3 plus TCA sine 30 minus what? The weight. Why it's minus? Because it's acting in the negative y direction, okay? So minus 98.1 equals to 0, or we can take this term to the other side to be positive, 98.1. So here, one equation 1 unknown, the unknown is TCA, okay? So we can find it to be 42.61 newtons. After that, we can use the hint or our third equation, this one, okay, to find the value of TCB. So it will be twice the value of TCA, the tension force in cable CA, okay? And we'll get the value to be 85.2 newtons. Now let's move on to the next problem. Here it's also a 2D problem, okay? So we have two equations of equilibrium. Determine the force in each cable. So we will need to find T, the tension force in cable CD, the tension force in cable BC, and the tension force in cable AB. And the force is always tension, as we agreed, okay? And the force, determine the force in each cable and the force F. And we need to find this force F needed to hold the 4 kilogram lamp. So here the mass is 4 kilogram. And first analyze the equation at B. Okay. Here we have this point where in this chapter we're dealing with the equilibrium of a particle. So we have particle B and particle C. And we have, like, we should have the maximum number of unknowns to be only 2 unknowns, okay? So if we notice here at point C, we have the force F, first unknown. We have the tension force in cable CD and the tension force in cable CB. So we have 3 unknowns, correct? So we can't solve it because we have only 2 equations, summation of force in the x direction and summation of forces in the y direction. So we have to first begin with point B because we have only 2 unknowns. The tension force in cable BA and the tension force in cable BC, and here the mass is given. So the weight is known, okay? After we find the tension forces in these 2 cables, we can, so after finding TCB from particle B, okay, from here, we are going to move forward to point C. So we will be left with only 2 unknowns, okay? And we can apply our equations of equilibrium. So first of all, we took point B. We have the tension force in cable B and the tension force in cable BC, and the weight of the lamp. Let's give it the mass to be 4 kilogram multiplied by G, acceleration, and we will get the weight to be in newtons, 39.24. Now, we can apply easily our 2 equations, right? So, beginning with summation of force in the x direction, we have the tension force TBC cosine 30, the angles are given, okay, minus, because it is in the negative side of the x-axis, minus TBA cosine 60 equals to 0. So TBC will be what? We'll take this to the other part, so TBA cosine 60, and we will divide cosine 30, both sides, okay? So here, this is our second equation. Now applying summation of forces in the y direction, we will get what? TBA sine 60, okay, plus minus TBC sine 30. So here the component in the vertical direction of the tension force, the cable BC will be negative y, because sine 30 will be here. So it's in the negative y-axis. So minus TBC sine 30 minus, because here the weight is also in the negative y-axis. Okay? So minus 39.24 equals to 0. Now, use 2 in 3, I will use the value of TBC in equation 3y to be left with one unknown only. So here, or you can say, okay, we have two unknowns, TBC and TBA, TBA and TBC, and we have two equations, we will solve them, okay? So here we can use the value of TBC here, which is equals to what? TBA cosine 60 over cosine 30, multiplied by sine 30 and plus TBA sine 60 equals to what? This, I took this value to the other side. So equals to 39.24, one equation one unknown. We can get the value of the tension force in cable B in newtons. Now here, from equation 3 again, after getting the value of TBA, now this value is known, okay? So here from equation 3, one equation, one unknown. This TBC is unknown. So we can, after substituting the value of TBA, okay, we are left with one equation unknown, and we can get straightforward or directly the value of the tension force in cable BC to be 39.25 newtons. Now we have found the tension force in cable BA and the tension force in cable BC. Now we can move forward to particle C, because we are left with only two unknowns, the tension force in CD and the unknown force F. So here, the tension force in cable CD and the unknown force F. And this value, we have found it from applying the equilibrium equations at point what B, okay? So its value is 13.25 newtons. Now, applying summation of forces in the x direction, TCD cosine 30 is positive, okay, minus TBC cosine 30 will be negative, okay? So minus 13.25 cosine 30 equals to 0. So one equation, one unknown, we can get easily the value of the tension force in cable CD in newtons. Now, taking the summation of forces in the y direction, what we'll get? We'll get, we have minus F plus TCD sine 30, okay? And from TBC, what we have 39.25 sine 30, okay? So here plus TCD sine 30 plus 39.25 sine 30 minus F. Now the value of TCD, we have already found it from here, okay? So here we are left with one equation, one unknown. The unknown is the value or the force F, and we can get it, okay? It will be 13.25 newtons. Now moving on here, we have the idea of the springs. The same idea applies. We have these two equations, summation of forces in the x direction and the summation of forces in the y direction, okay? And we have to use the force of the spring to be Fs equals to the spring constant K multiplied by the stretch S or delta X. Anyway, here we can start with point. Let's read first the problem. The unstretched length of spring AB is 3 meters. So the unstretched length here The original length L, 0 is what? 3 meters. And the stretch length after applying this force or the weight here, it is 5 meters. We have found it from what feasible. Like here we have 3 meters, this triangle 3 meters, and this length is 4 meters. Okay, so here this is right angle. Here it's 4 meters, and here the height is 3 meters. So we can get this value to be 5 meters. Okay, by saying okay, 4 squared plus 3 squared, yeah, and square root will get 5 meters. Anyway, so here from this information, 3 meters, we can calculate the spring force in cable AB to be equal to what? Spring constant KAB, okay, which is what? 30 newtons per meter, multiplied by the stretch, which is like the final length or the stretch length, which is 5 meters here, minus the unstretched length, which is given 3 meters. And we'll get the force to be what? 60 newtons. Now, if the block is held in the equilibrium position shown, determine the mass of block at D. So what's required from us is to find M at D. Okay. Here we can start at point A. Here it's point A. Okay. So we have what? FAB, spring force on cable AB, and FAC. Now here we have already found it to be 60 newtons, and here we have another unknown, which is the spring force in AD, FAD. But from point D, we can like draw the free body diagram to be what? Here, FAD, spring force, FAD equals to what here? Point D, it's point D, equals to what? The weight. So FAD, we can replace it directly by the weight. So it's equal to the weight, okay, which is M mass multiplied by G. Okay, so here what I did here, FAD, okay, it's equals to the spring constant multiplied by stretch, but it's equal to the weight after applying after doing the free body diagram of particle D. Okay, so directly I can replace it. So here we have already found the value of the force, spring force on cable AB to be what? 60 newtons. Okay, and here the triangle, I've drawn it. The dimensions are given 3 meters, 4 meters, and I have found the 5 meters. Okay, and here the angle I can found it by, here it's 3 meters and 3 meters, here it's 3 meters, so I can say what here, let's say theta. So theta is equal to what? Tan inverse 3/3, which is 1. Okay, which is the theta will be 45 degrees. Okay, so here applying the summation of forces in the x direction equals to 0. So here, first of all, we have 60 newtons, 4/5, okay, in the positive x-axis direction, minus FAC cosine 45, okay, equals to 0. One equation unknown, we can find the value of FAC to be what? 67.88 newtons. And by the way, we can find easily here the angle. If we don't want to use the triangle, we can say, okay, theta is equal to what? Tan inverse 4/3. Okay. Now applying the summation force in the y direction. So here, let me erase this first. Okay. So here I have FAC, which I've already found the value of it to be 67.88. So sine 45 or cosine 45, it will not matter because cosine 45 equals to sine 45. So it will be positive, the component in the positive y direction. So 67.88 sine 45 or cosine 45, okay, plus also here 60, 3 the vertical length over 5. So 60 multiplied by 3 over 5 equals to what? Equals to W. Or I can say minus W equals to 0, or I can say equals to W direct. So the positives equals to the negatives, okay? Which is equal to mg. So m multiplied by 9.80. So I can find the mass which is the required, okay, from this problem to be 8.56 kilograms. Now here I have another problem. Determines also to determine the maximum mass of the land that the core system can support so that no single core develops a tension exceeding 400 newtons. So here it's given that here any core should not exceed a value of 400 newtons, otherwise failure will happen. So, okay, the same process for each particle, I'm going to apply my equations of equilibrium. So, summation of fx and summation of fy, both at C and particle D. And I'm going to keep the results in terms of M max. So write everything in terms of M max, and at the end, I will take the controlling tension force, which is the maximum tension force. So let's say TCD will have or will be the largest tension force. So I will take this value, which will be in terms of M max. So I have a coefficient, let's say A, or let's say 6.2 multiplied by M max equals to what? I will equate it by 400 newtons, which is the allowable, the given, okay, limit. So 400 newtons, and I will get the M max, the maximum mass of the lamp, okay, for safety. So here, free body diagram for particle D, I have the tension force in cable DE and the tension force in cable CD, correct? And also I have the weight of the lamp. So M maximum multiplied by 9.81, and here the angle is given to be 30 degrees. Anyway, here taking the summation of forces in the y direction, I will have TDE sine 30 will be positive, okay, minus T weight, which is M maximum multiplied by 9.81 plus 0. So TDE, I will, as we agreed that every tension force, it will be written in terms of M maximum. So it will be 9.81 over sine 30 multiplied by M maximum, and this is our first equation. So at the end, I will take the largest tension force and equate it by 400, because this tension force is the controlling one, and from it we will get the maximum mass allowable, okay, which is in fact will be the least value, okay, not the maximum value. Here they mean the maximum mass allowable, so that failure, we can avoid the failure of this system. So here, taking also the summation of forces in the x direction for particle D, so we have TDE cosine 30 positive minus TCD equals to 0. Okay, so TCD will be what? I will take TCD out to the other side, so we will get TCD equals to TDE cosine 30, and TDE we have already found it to be 19.62 M maximum. So I will replace TDE by 19.62 and maximum plus sine 30, I will get TCD to be 16.99 and maximum. This is our second equation. So I have found TDE and TCD. Now I'll move to particle C, okay, to find the tension force in cable AC and BC, and they will be also in terms of M maximum, okay, because the tension force in cable CD is in terms also in terms of M maximum. Okay. So moving on here, here is our point C. We have TCD, okay, TCD, which is equal to what? 16.999 N maximum. And here TCA, the triangle is given, okay, so TCA, and finally the tension force in cable BC, okay, and here we can note the angle is given, so here the angle will be what? 45 degrees, okay, so here the angle is 45 degrees. Now applying our equation, we have here 16.99 M maximum minus TCA 3 over 5, okay, the negative side, minus also TCB, what? TCB cosine 45. We'll get this component to be also the negative side, equals to 0. So this is our third equation. Now summation of forces in the y direction, we will have what? TCA 4 over 5, the vertical length over 5, okay, this will be the positive direction, and here TCB sine or cosine, to not matter actually, it will be in the negative direction, okay, so minus TCB sine 45 equals to 0. So here TCA will be equal to what? TCB sine 45 multiplied by 5 over 4, and we will get TCA equals to 0.884 TCB. So now here we can use equation 5 and equation 3. Okay, so we have found TCA, so we can put the value here, 0.884 TCB, and we are left with one equation, and we can get TCB in terms of M maximum. Okay, so we have 16.99 M maximum minus 0.884 TCB multiplied by this ratio 3 over 5 minus TCB cosine 45 equals to 0. So here we can note TCB will be only in terms of M maximum. So this is our sixth equation. And also to find TCA, we are going to use, okay, equation number 6 and equation number 5 here. Okay, to find the value of TCA. So TCA equals to what? Equals to 0.884 TCB. Okay, and we have already found TCB to be what? 13.7 M maximum. So after substituting, we will get TCA equals to 12.11 M maximum. So here we have all the tension in the cables in terms of what? M maximum, and the controlling or critical tension force is in cable DE. Okay, and hence we can, or you can say, okay, I will substitute for every tension force by 400. So by 400 here, and you can find out the value of M maximum from each equation, and you will find that you will get M maximum here to be the least value from the equation of TDE equals to 19.62 M maximum. Okay, because here it will be divided by 19.62. So 400 divided by 19.62 will give us the least value of M maximum. So we get 20.39 kilogram. Okay. So in the other equations, you will get the M maximum will have a value larger than 20.39. So here is the least mass allowable. Because say for example, you got from this one 22 kilogram, and here 24 kilogram, and let's say here 26 kilogram. So the system will fail at 26 kilogram, okay, and 24 kilogram and 22 kilogram. But you will choose the least allowable mass, which is 20.39. So you make sure that the mass shouldn't exceed a value of, say for example, 22 kilogram or 24 kilogram or 26 kilogram, otherwise it will fail. Okay, so if you choose the least value of the mass, 20.39 kilogram, you will make sure that the system will not fail if we have chosen the mass to be 22 or 24 or 26. Okay. Here we have a 3D problem. So what's the only difference is that we have summation of what? Summation of forces in the z direction. So here what's required is determine the stretch S in each of the two springs. So don't worry, we will, as usual, we will apply our three equations if we are dealing with a 3D problem. Okay, and after that we are going to find the value of the force FOA, the spring, and F, spring force of the cable, OB, okay, over the spring OB. And after that we are going to use F equals to KS. The K are given, okay, and simply we can find from this equation the value of the stretches. But here it's easier to use the Cartesian vector notation in 3D. So first of all, we have to use what? To find the Cartesian vector notations for all the forces. So here, for the force FOC, okay, the position vector ROC, here it's the origin, so the coordinates are 0, 0, 0, and at point C, it is what? 6, okay, so we have moved here a value of 6, or a distance of 6 meters. Then in the y direction we have moved 4 meters, and in the z direction we have moved, or the distance is 12 meters. So 6, 4, and 12. So ROC will be actually what we will be extracting the coordinates of C minus the origin of. So 6 minus 0 plus 4 minus 0 j hat plus 12 minus 0 k hat. Okay, and so here's the vector ROC, and the magnitude will take like the square root 6 squared plus 4 squared plus 12 squared, and we get 14 meters. So the Cartesian vector notation of the force for the cable OC will be the magnitude multiplied by the unit vector, which is FOC multiplied by the position vector over the magnitude. Okay, so 6 over the magnitude 14 multiplied by FOC, the magnitude I hat, plus 4 over the magnitude 14 multiplied by the magnitude of OC, j hat, plus 12 over the magnitude multiplied by the force FOC, okay, and k hat. So we'll get, this is our vector notation for force FOC. Now FOA, regarding FOA, we can note here, it is simply on the y-axis, but it's in the negative. Okay, so here it will be only minus FOA, the magnitude, j hat. Okay, and regarding FOB, we cannot also, it's on the x-axis, but it is in the negative side. So FOB minus the magnitude FOB I hat. And regarding the fourth force, which is the weight, we cannot, it's also on the z direction, but it is on the negative side. So here F equals to minus 196.2 k hat in newtons. Okay. Hold, okay, 20 kilogram multiplied by 9.81, we will get 1962 in newtons. Okay, or sorry, 196.2 newtons. Anyway, here we are going to apply our three equations, equilibrium equations. Okay, so here I have this term I had 3/7 FOC minus FOB, this term is also in the x-axis direction. So minus FOB equals to 0. Here, I will sum the j hat terms. So I have this is a j hat term 2 over 7 FOC j hat minus FOA j hat equals to 0. And regarding the k hat terms, 6 over 7 FOC, okay, plus this term, which is minus 196.2 equals to 0. From these three equations, we have three unknowns, and we can find them easily. So from equation 3, we got the value of FOC. From equation 1, we can find the value of FOB, and from equation 2, we can find the value of FOA. Okay. Now we will use the spring force equation. So FOB equals to spring constant multiplied by stretch. So the stretch will be the force over the spring constant, correct? So we have already found it. So 98.1 newtons over, it's given in the problem, 300 newtons per meter, okay? So I will get the result in meters, but I multiplied by 1000 to convert the unit to be in millimeter, okay? To millimeter. And also the stretch in the cable OA, similarly, the force over the spring constant is also 300, and we have already found the force FOA to be what, 65.4 meters. And we will get the answer in meters, but I have multiplied by 1000 again, and I will get the stretch to be 218 millimeters. Here is our final problem. Okay, it's again 3D problem. Let's read it. If the mass of the flower pot is 50 kilogram, so 50 the mg, the weight is mg, and we'll get 490.5 meters. Okay. Determine the tension developed in each wire for equilibrium. So we need to find here FAB, FAD, and FAC. Note that the maximum number of unknowns here, we should have only 3 unknowns because we are dealing with only 3 equations in 3D. But later on chapter 5, when we are dealing with the equilibrium of a rigid body, we have 6 equations of equilibrium. But now we are dealing with a equilibrium of a particle, okay? Of a point. So we don't have a moment, the moment equations. Anyway, here is the weight, okay? It will be minus k hat because the z direction, z-axis direction is positive upwards, okay? And regarding the force and the tension in the cable FAB and the cable AB, it is in the y-axis direction, but it's positive, okay? So j hat, it is in newtons and newtons. Now regarding FAD and FCD, we should use the position vector, like as we did in chapter 2. Okay, so FAD, the magnitude multiplied by the unit vector. Okay, so the position vector of AD, now point A will have coordinates of what, 0, because it didn't move in the x direction, 6 meters in the y direction, and it didn't move in the z direction, so 0. Now regarding point D, it will be what, 1.5 meters, but the negative, because here is the positive, and 0 here because it didn't move in the y direction, and 2 in the z direction. So here positive 2. Regarding point C, it has moved 2 meters in the positive x direction, 0 meters in the y direction, and 3 meters in the z direction. So we are starting with RAD, so the coordinates of point D minus the coordinates of point A. So here, the coordinates of point D, here the coordinates of point D minus the coordinates of what, point A. So minus 1.5 minus 0 I hat plus 0 minus 6 j hat plus 2 minus 0 k. Okay, it will be in meters. The magnitude, and the magnitude will find it to be 6.5 meters. Now we are ready to write the force of AD in the Cartesian vector notation. So minus 1.5 over the magnitude, which is 6.5, multiplied by FAD I hat minus 6 over the magnitude 6.5 J hat. Here I forgot to write FAD and here also FAD. Okay, so here it will be plus 2 over the magnitude 6.5 multiplied by FAD K hat. And there it is in newtons. Now regarding the force of AC, same process. We are going to say, okay, the coordinates of point C minus the coordinates of point A. So 2 minus 0 I hat plus 0 minus 6 J hat plus 3 minus 0 K hat. Okay, and the unit is in meters. Now the magnitude will be 7 meters, and we're ready to write it in the Cartesian vector notation. So 2 over 7 FACI hat, then minus 6 over the magnitude 7 FACJ hat, then plus 3 over 7 K hat newtons. Okay. Now taking the summations, the x, y, and z direction, we are going to find out our 3 unknowns. So here we are going to collect first of all the I hat terms from our previous equations. So here minus 1.5, here first of all minus 1.5 over 6.5 FAD, okay, plus 2 over 7 FAC, okay, and here we don't have I terms, okay, so equals to 0. This is equation number 1. Then collecting the J hat terms, we have here minus 6 from this equation, minus 6 over 6.5 FAD, okay, and from here also we have minus 6 over 7 FAC, okay, and we should not forget this J hat term, okay, which is the tension force in cable AD. Okay, so plus FAB, so here plus FAB, here plus FAB. And finally, summation force in the Z direction. Also, we should not forget here the K hat, because this is from the weight, okay? So minus 490.5 plus 2 FAD over 6.5, this term, okay? And plus this term, 3 over 7 FS, okay, equals to 0. So 3 equations, 3 unknown. From the calculator, we can say mod 5, 2, okay, and we can arrange them. So here FAD for our first unknown, the second unknown, our second unknown is FAB, and the third unknown is FAC. Okay, so equation number 1 here, FAD is minus 1.5 over 6.5. FAB, we don't have any term for FAB, so 0. And finally for FAC, we have 2 over 7 equals to what? 0. From equation number 2, we have what? 6 minus 6 over 6.5 FAD, and FAB we have the coefficient 1, okay, so 1, and for FAC we have minus 6 over 7 equals to 0. Now, from the third equation, we have for FAD we have the coefficient what? 2 over 6.5, okay, and for FAB we don't have any term, so 0. And for the force FAC, we have 3 over 7 equals to what? Not 0. We are going to take this term to the other side, so it will be positive. So putting these values in the calculator when you are pressing on mod 5.2, okay, for solving 3 equations, we will get these values in newtons, okay. So here I got this number, this answer in newtons, but I converted it to be in kilonewtons after I have divided it by 1000. Okay, so by this we conclude our second tutorial for chapter 3. Hoping that it was useful, and see you then.